Hello again, welcome back to Sailboat building video series. This video is particularly interesting because we're starting to build the boat. Kind of. On computer at least. If you're new to the channel, my name is Panu, I'm an architect and a sailor. That sounds familiar. Whatever. And I have already built this big CNC router and I'm going to use that to manufacture parts for this sailboat project. And right now we're in the middle of doing digital lofting of the boat. So let's jump just right into it after you have subscribed to the channel. All right. And what that actually means and how it differs from the traditional method, let's check it out. So as you may know, I have already done a 3D model of the boat, which you can see right here. But in order to manufacture things from the model, we have to do some additional things. Well, if we start just from the hull right here, you can see that the hull is basically just a 3D modeled shell of the boat. So in order for me to really build this, we need some kind of measurements, shapes and forms from this model to make template, molds, frames or whatever we need to actually cut them with the CNC. Traditionally, lofting is getting the table of offsets from the boat designer, which is basically just a spreadsheet of numbers that you draw on 1:1 scale floor or some paper or whatever you use, kind of draw the actual shapes of the boat in different positions. That can be quite time consuming and, well, hard is not maybe the right word, but definitely a lot of work. But as I have this amazing CNC machine, I can do all that work with the computer. So I'm just taking kind of cut-offs from this model and form the shapes out of that. It's not that simple, but let me show you how I have done this. So I am using ArchiCAD as my CAD software, which is not the best software to design a boat, but well, I'm really familiar with it, so it suits for me. But the boat hull is modeled with Rhino, which I have right here in the background. So if we take a look at this Rhino model and turn off these cutting planes, you can see that here we have a half model of the boat. This can be a little bit confusing because, of course, when naval architect models the boat, he models the outside surface. And if I want to make the frames out of that, I need to make an offset from that outer shell by the thickness of the hull itself. So that is what I have done here in the Rhino, so that I can get the interior surface of the hull. All right, so now I have an interior layer separately here, which I have used to slice this model. So if we take this cutting plane here, you can probably notice these perpendicular lines here. They are the positions of the stations or the frames in this case. So for example, if I put this cutting plane here and activate it, I can get perfect cut from the half of the hull, and this surface is now the inside of the hull. So after that, I just made a 2D drawing of that shape and put it here like so, and then I exported these to the ArchiCAD and then I can modify them a little bit over there. There is a couple of important things to be considered when doing this work like this. Every time you kind of modify these lines, they can change a little bit. And that's because this hull shape is actually formed with mathematical surface. So it is formed with the curves that are mathematical expressions. They are not polygons, they are not lines or anything like that. So when I do this cut, it is kind of a rounded estimation where that curve really goes. And it is never going to be perfect, but it sure is accurate enough. So we're talking about like a fraction of a millimeter here. But there's different methods how these programs grab those numbers, and that has taken some time, and I have done this job like 3 or 4 times to get it right. So the first problem is that this CAD program tends to do kind of straight lines from the curve. So it just chops the curve in the very small straight lines, and that's not the way I want to do it. A little bit of googling and a little bit of fiddling, I managed to find commands that make those lines as arches from a circle, and that's important because the CNC router understands only straight lines and portions of a circle. So there is not such thing as a compound curve or anything like that. They are just parts of a circle or straight lines what the machine actually cuts. So now I have already done this part of the work in a way that now this, if we change to the frame number 1, which is the first frame here, we have this line here which is now activated, and you can see that it has a bunch of these black dots. Those are the nodes of the curve, but all the middle lines between are actually curved parts of a circle. So it goes smoothly and it changes smoothly, so there should be no like hard edges in here. So that was kind of a technical problem, and it took some time to figure out how I get these lines perfectly there. Because I couldn't do that in the ArchiCAD itself because, well, the problem is the same. So this is part of the 3D modeled surface that I imported in ArchiCAD, and you can see the section line here. So if I take my polyline and make a line on this, it kind of should work. Here we have a line that was created from that section of that model. But in ArchiCAD, it really doesn't understand that it should be curved, but these are straight sections of lines. They can be accurate enough, but I didn't want to risk it, so I didn't do it that way. But I imported every frame shape from Rhino as a curved polyline. So these shapes, this red one and blue one, these are the outer shapes of the frame 1. This red is the forward edge and the blue is the aft edge. And that brings us to the shape of the frames. So if you take a look at the construction method of this boat, we are going to have frames and a keel and a keelson, and then there is this forward stem part. But the frames are of course the most important pieces of the structure because they form the shape of the hull, and they should be pretty accurate and pretty well made as well. And they are the parts we're going to start the build with. What I showed you earlier were the lines of the frame 1. We can just separate this form here. So you can see that the frame here has a kind of forward edge and the aft edge, and of course the shape is different from each of the edges. So I have now imported from the Rhino model the forward outer edge and the aft outer edge of the frame. So when we know those lines and the distance between them, which is in this case is 80 millimeters, we can make a template or mold for this frame. So these are going to be laminated frames, and I have figured out a system that I'm going to use to actually build them and make the form or the mold with the CNC router. One more thing before we continue, let's go back to the model here. So this is kind of the basic structure without the outer shell frames, the keel, and these parts, which name I can't remember right now, but anyway. So these frames are laminated with the molds that I'm going to do with the CNC. The keel section is also laminated. For that we can't really do any kind of mold, but it's more easy to do because you can always shave off the excess from the outside. Probably the most difficult and complicated part in this are these longitudinal beams I have now modeled them, and they are forming the shape of the deck as well as they are supporting these frames. And I think these are one of the first things that is gonna be put together inside of the boat. But now when I have modeled them like this with the 3D model and I have these frames here, I can actually subtract the shape from those frames and kind of form a mold or surface where this clamp molding can be laminated at. So there's a bunch of things that need to be taken into consideration when making these molds for these frames. So all these shapes on the top side here, shape that will form the floors and everything should be on those frame templates or molds, if you think about it a little. In this way, the boat shape has already been lofted out from the plan. So the initial plan in this case is the outer shell 3D model of the boat. Then I make an offset from that surface to form the inside surface of the boat. Then I can use that to make sections from every part where I need the shape. And then I just fiddle out a little bit and then I can get a cut lines for the CNC. Basically, it's not that complicated, but it needs some fiddling and testing to get it right. But now, when that is done, I think I could demonstrate the system to form these frames. But if we take just this one half frame here, I have done this in a way that the outer shape is of course the hull shape, but the inside shape is always straight, so it makes it quite a bit more easy to form these. So if we take a look at this shape, we know that both edges, the forward and the aft edge, are straight, so we can use this surface as a flat surface and make a plywood mold to that shape. So let's try to do something now. So now I did a separate form from this surface right here. So if we pull it a little bit, so if we say it's a 12mm plywood, now I have this plywood sheet right here, which can be of course cut with CNC quite easily. So this outer edge will form the shape of the hull from this edge. So if we do a similar thing to the other side, like this, and let's say it's 12mm as well, you can see that now we have two straight pieces that can be cut with CNC that form the outer edges of the frame on both sides. Now we just need to figure out the way to connect these two pieces with some blocks between there to form this actual shape. So if we now make some shapes here like so and something like this, I don't know exactly how I'm gonna do this yet, but and put these on the other side as well. You can kind of see what's happening here. We can kind of feel this between here like so, and if I now remove the actual frame from back there, we can see that now we have this surface back here to put the lamination material against and just press it against these from here and form the frames between. After the glue has dried, we can then shape this edge to those edges and then just flip these around and do the other side. So I think this is kind of a simple way to do this. Of course, I have to model these frames quite accurately, get these forms done really well, so all the notches and stuff that need to go there should be in there already. So that is basically the process I'm gonna start with by making these kind of molds from every frame and then start cutting them with the CNC. And that is basically it. It just needs quite a bit of work. But now I have all the shapes and I will now continue the modeling work and we'll see you back in just a moment. All right, now I have done some more fiddling with this thing, and now I have the first virtual mold ready to go here. Let's take a little closer look. So this is the frame number 1A, which is the first of the two frames. Let me show you just the principle of this frame. So these are the frames, and there are 15 of these frames altogether. The naming is maybe a little too confused. The first two are 1A and 1B because they are on the station 1. And then on the middle there are 3 frames that are 7A, B and C. So they are on the middle mast, and these 3 forward ones are on the forward mast. So that's the basic layout of the frames, and they are not uniformly aligned. They are kind of in the places where there are bulkhead or something else, or just kind of a proper gap between. So they are where they are, and their place are fixed now, so these won't change anymore, I hope, because yeah, you know the drill. Now I have been concentrating to this first frame, mainly because this is the only frame that will not have actual floor on it. It's just a kind of a ring frame. If you take a look right here, this is the actual frame, and there will be a deck beam across there. Here we have the mold of the first frame and the second frame, you can see there, but it's not ready to go on the floor sections, so don't mind that. But this is the mold, and the idea here is now that these two yellow parts are CNC cut plywood sheets, and the red parts between there are spacers that align perfectly with these bung holes here. So in theory, when I cut these parts, these yellow parts, and put them together, and then these red parts, and connect these with those bungs, it should give me perfect mold for laminating that frame around this. Now the frame is actually in there as well. So now you can see that the frame outer edge is aligned with these two molds. And after lamination, I can easily plane this surface down to these edges. So it should be quite straightforward. And these inside surfaces, these are all straight, so they shouldn't need any additional cutting after the lamination process. Then there is this hole, which seems to be hole, but this is actually the hole for the side beam, whatever goes through here. It's a hole because on the other side there is this spacer. But anyway, I think this will work quite well. In practice, I think I'm gonna do kind of a plywood sheet underneath this whole thing, lay that down on the floor so that I can push bungs on these round holes into that plywood sheet. That should keep it straight. Maybe I could purchase very thick and good quality plywood sheet that should be the straight kind of workbench when laminating these things. Yeah, I think this will work. So let's put some more layers on here. So like this it should come together. There's a bit of lag when I'm recording the screen. For this frame number 1, there's going to be bulkhead right against it, and this section will be watertight as well, so there's no limber holes or anything like that in this particular frame. It seems to be quite good right now. So okay, now there's a little bit more layers on, and here you can see the side moldings. It goes through or against these frames right here, and then there is this side deck and bulwark. Okay, if we take a look how I'm gonna lay this whole thing down. So the first part, of course, you have to imagine this is upside down when build starts. So these two parts are the first ones to lay down, and they form the bulwark, which is completely straight, as you remember from earlier videos. But I will do CNC machined structure from plywood when these are actually connected together on the middle from multiple points, so they should kind of click down and form the shape of the bulwark And these are all now done in a way that these frames should fit perfectly on this shape. And then just I have to figure out quite a bunch of molds and temporary structures to hold everything against the shed floor and together, and how I'm gonna put these frames and stuff. So there's still quite a bunch of things to figure out in the actual construction schedule and the order and things like that. What I'm thinking at the moment is that I'm gonna start with these bulwarks, possibly install these side decks already when the boat is upside down, and maybe these bulwarks inner walls as well, because the frames are coming against this bulwark wall. That should be easy enough to do, but we'll see. Nothing is written to the stone right now. I'm thinking this thing every day. So one little detail is that there's actually 2 of these bulwark plywood sheets, and I'm gonna do the upper one. So this is against the floor, and this is on top of that. And I'm gonna do these slots on every frame. So the frame has a slot on the top side, so it should just snap down to these slots if everything goes like it should. So that should keep them on place when filling everything. Of course, these kind of things are possibly only if you're doing this thing with CNC. Otherwise, the method would be totally different. But all right, I think I'm not gonna continue right now forward with these frames, because in a few days I'm expecting some more material from Naval Architect, especially the mast steps and the keel steps, and some additional information of these floors, these parts here. So they will affect quite a lot of these frames, so not gonna waste time on those right now. But I think what I'm gonna do is to actually try to manufacture this first frame quite soon. First, I'm gonna do some kind of test assembly or test arrangement and try out this method of laminating these frames, because I have never laminated a wood composite structure with epoxy before. So I think I'm gonna try something before I'm gonna do a major structure things for the ocean going vessel. Of course, the next job is to make actual cut files from these plans, and I think I'm not gonna need actually model all of these things, because on these 2D sections I can get all the measurements right here and have these forms that can be exported straight to the CAM software. So I don't need to model everything and every frame to make things right, but most likely I'm gonna model some of them and just to make sure that everything fits like they should. This is a very interesting topic, and I could yammer on hours and hours, but if you have anything to ask or suggest, suggestions are very, very welcome. Put your comment down below and give me a like and subscribe to the channel. But the next video will be something of the 3 topics of the shed or the CNC or the boat plans, or maybe a wild card. I don't know. We'll see you in the next video. Bye.